What's up, Chem Gang? I'm going to be doing the reaction called hot ice, and it starts with baking soda and vinegar, but you use 2 liters of vinegar and 8.5 tablespoons of baking soda. So to know before I start this reaction is that baking soda has a chemical formula of NaHCO3, and vinegar has a chemical formula of CH3COOH. And this is before. When you're putting in the baking soda, you want to make sure to put it in slowly so it doesn't explode. After all the baking soda is put in, make sure to stir it all the way so it looks clear like this again. When you're all done stirring, make sure to turn on the flame underneath the pot on low, as low as it can, to boil the solution. Boiling is the longest part. It'll take a couple hours. When the reaction is occurring between baking soda and vinegar, the molecules actually split up into sodium acetate and water. As this reaction is happening, it is releasing heat and CO2 gas, which is making it an exothermic reaction. So the pot has been boiling under a low flame for about 2 hours now. And as you can see, or maybe not see, I'm going to get some light on it, there's a precipitate starting to form on the top, and it's actually starting to crystallize on the top. But you can see it a little bit on the sides right there. It's actually gray, and what I have to do after this is I have to kind of break it up, and then after that, after this is all done boiling, I'll know it's done boiling because there will be a clear sheet, and you can see it on the top. And once I'm done, I'm going to fill this bowl up with ice and water and make it kind of an ice bath. And then I'm going to put the solution in this. I'm going to transfer it from there into this. And then I'm going to put it in here like that and let it sit for about an hour. And then once it's done, we'll have a cool reaction to look at. Checking up on it again. Getting really tired of just doing this. I'm just getting to burn my house down. I've been doing this forever. This is 2 hours and 45 minutes. Look, you can see the precipitate coming in now. You see those little marks? Yeah, that's parts of the precipitate that haven't formed yet. It's just chilling, and I can't take it out of this thing until it's fully precipitated. And yeah, the precipitate is a little bit more clear to see now because those bubbles are not on the bottom. They're on the top, and they stopped. The precipitate is starting to form, and phone got foggy. Okay, so it's starting to form. You see how the bubbles are just stopped there? So it's starting to form. So it was sitting in the ice bath for about an hour. And so now we're going to see if it works. I'm going to walk over here. I'm going to open this. I'm going to grab a spoon. I'm going to walk back over here. We're going to see.
In the experiment, the ions formed from the solution are allowed to move freely and show a high amount of disorder. When the ions combine to form crystallites, their freedom of motion has become restricted. Hot ice is an example of spontaneous crystallization. Salt solutions that have been processed in this way so that their temperature can drop below their regular solidification melting level and still remain a liquid are called supercool or metastable liquids. Laws of thermodynamics explain that for an experiment showing a decrease in the entropy to occur spontaneously, such as a solid to precipitate, the experiment must give off heat. So the solid crystallite of sodium acetate will warm itself up and sodium acetate precipitates from the solution. Now this is what should have happened.